Our next presenter is Vishruthi Manickavasagan from the Duluth Campus, Civil Engineering.
Can you imagine driving on roads of Minnesota with less number of potholes? Well, at the end of this presentation, you might be able to imagine that. Let's get started. So what do you think about these two images? Image A is a road with heavy traffic called the high volume road. Image B is a road with barely any traffic called the low volume road. The problem here is that more often they design the low volume roads using the same mixed design procedure as that of the high volume roads. What is a design? You usually design something to prevent it from failure, right? So in case of high volume road, the failure like the depression in the pavement, cracking are mainly due to heavy vehicle loads. But in case of low volume roads, the failure is mainly due to weather changes. What actually happens with the high volume road design is that we make asphalt mixtures with 7 to 8% air content and place them on the field. Over time, due to heavy vehicular movement, the asphalt layer undergoes compression. The 7 to 8% air content reduces to 3 to 4% air content. And this dense asphalt layer protects the pavement from failure due to weather changes. But in case of low volume roads, if you are going to place an asphalt mixture with 7 to 8% air content on the field, is there enough load to cause the compression? No. So what happens is that the excess air content in the asphalt layer attracts the moisture from outside and deteriorates the pavement, giving rise to potholes and temperature cracking. Therefore, for our research, we adopted Superpay 5 mix design methodology. That is, we produced asphalt mixtures with 5% air content. These mixes being quite dense by itself and does not require much further densification. They protect the pavement from failure due to weather changes and low densification factor. For our research, we developed 6 asphalt mixtures. 3 conventional Superpay mixtures, which is currently used in Minnesota with 7 to 8% air content, and 3 Superpay 5 mixes with 5% air content. As you can see, the graph represents 2 types of mixes and its crack resistance. The strength test showed that Superpay 5 mixes gave higher crack resistance. Therefore, adopting Superpay 5 mixes for low volume roads, especially in cold climatic region, will give us better durability and will be cost effective as it reduces a lot of repair works. This research was funded by MnDOT, and these results will aid MnDOT produce better mixes for the roads of Minnesota. I think now you can imagine driving on roads of Minnesota with less number of potholes and especially less construction activity during the summer months. Thank you.